I'm inviting now to share the presentation Jinsongdi Yu. With the modular approach helps bridging standard-based multidisciplinary imagery and gridded data. So maybe in the meantime, while Jinsongdi is starting to share the presentation. Are you still here, Jinsong?
Yes, it's Jinsongdi speaking.
Yes, perfect. So while you are starting to share the presentation, so maybe you're aware that ISO TC211 last year, before the 50th plenary week, started a challenge by the initiative of the chair, user story challenge, and with which ISO TC211 started to collect different user stories, good practices, implementation of location standards around the world. And this presentation today is one of those. So please, Jinsongdi, the floor is yours.
Okay, thank you. Okay, this is my talk. Modular approach helps bridging standard-based multidisciplinary imagery and gridded data together. And this is based on ISO 19105, geographic information conformance testing and testing. Okay, big data is quite a hot topic in earth science market. We have manifold big data in standardization stream. For example, we have coverage, features, and etc. ISO, OGC, W3C, IETF, and several famous international standardization organizations have contributed greatly to standardization based on the standardized sheets. The standardization work has the potential to solve a large range of questions today in the context of big data. Actually, not on big data assets, but also on analytics on variety of data. Then the problem is how we can test this together for our standardized solutions. In ISO or OGC, coverage data and service related standards contribute greatly to imagery interoperability by demonstrating of convenience of the standard-based techniques for Earth science system. These standards include service model, protocol binding, encoding format, data model, etc. More is coming underway. Research community can continue to use different standardized technologies and best in mixed mode to address the analytic challenges. This is our standardization story. We are using the ISO and the OGC coverage-related standardized solutions to demonstrate our national forest city, Fuzhou. A specification-oriented modular approach is adopted to achieve reliable interoperability by orchestration a variety of web coverage-related standards. For example, ISO 19163-2, ISO 19123-2, and the OGC WCS 2.0 series. The solution makes sure that the provided imagery and gridded data is concrete in terms of testable data structure, definition, and the integrated constraints, and therefore enable rigorous conformance testing down to single pixel level through the mechanism established in ISO 19105. Okay, this is the general testing framework. The solution is carried out based on some standardized implementations, for example, Rasterman, TND2, OpenLayer. The test scripts are customized according to the abstract test suite provided in the standard documents. The testing will check the solution is conformant to the standards. Here we use OGC team engine to customize the test suite, test scripts. Specifically, these are the standards we used for the solution. This includes ISO 19105 for testing, ISO 19123-2 for coverage, and actually this ISO 19123-2 it is also OGC CIS 1.0. And we also use ISO 19163-2 for imagery and gridded data. and OGC WCS 2.0 for service interfaces. Actually, these standards all follow modular approach. Therefore, we can implementations follows these standards can be ultra traced quite easily. Then I will go these standards one by one. But regarding the ISO 19105 implementation, a conformance testing framework is provided. See the figure below. In this framework, a standard or specification contains requirement classes, which are used to derive an abstract test suite. An implementation under test is derived according to the standard or specification. And then an executable test suite is implemented according to the abstract test suite. The executable test suite will test the implementation under test to determine if it meets the well-defined set of requirement classes as stated in the normative clauses. Finally, a test report documents the results of conformance testing by considering the dependency relationship among conformance classes. This is ISO 19123-2. These documents specify a concrete implementable conformance testable coverage structure based on the abstract ISO 19123. This document also defines the structure that is suitable for encoding in GML and many encoding formats. Domain model can be added to the coverage structure for use if needed. In this way, in this story, we use ISO 19163-2. Okay, then let's have a look at the ISO 19163-2. This document specifies an implementation schema based on the content models for geographic imagery and graded thematic data defined in the ISO 19163-1. In this story, we binding ISO 19123-2 and ISO 19163-2 together. In this way, our imagery can be served by OGC WCS 2.0. Then let's have a look at an OGC WCS 2.0. OGC WCS 2.0 offers multi-dimensional coverage data for access over the internet in a standardized way. It contains a core and several extensions. The core defines the basic coverage access functionality, downloading a whole coverage or some special temporal part of it. The service extensions add further functionality, phases, and the protocol bindings. This is the technical standard note for our solutions. We have logic N and O in our graph. N means each component passes the test according to the corresponding standard. O means at least one component passed the test. Then I will have a brief introduction on how to use, how to use ISO 19105. Actually, this depends whether you are an implementation developer or test developer, solution provider, or standard author. For an implementation developer, the developer needs to find the right modules in the conformance clauses and follow the corresponding requirements, pass it correctly, and implement the implementation. For a test developer, the developer find the right abstract test suite and derive the test accordingly. For a solution provider, the provider needs to find the implementation which implements the right modules and need to ultra trace this standardized based implementation in a proper way. Then find the corresponding testing and carry it out and test accordingly. For a standard author and for who wants to follow the modular approach, it would be better that the document is provided in a structured way that follows the modular approach, which means it needs to contain conformance classes, requirements, abstract test suite, and etc. Okay. Oh. Summary. In this presentation, in this standardization story, we have online analytic ready image data, which also trace a variety of web coverage related standards from ISO, W3C, OGC, IETF, and etc. And this story is based on existing standard-based approach, based on OGC WCS 2.0. Then we can use this to assess our data. And we can provide a concrete, implementable, conformance testable coverage structure as defined in ISO 19163 that conforms to ISO 19123-2. And follow the modular approach, we can do the overall assess. We can have a global validity of a cross-reference statement because there are dependency relations there. We can spot inconsistency and incompleteness among requirements, implementations, and test, and do the revision accordingly, either on standards or implementations or tests. Because I'm the project leader of the ISO 19105, and also the main contributor of the ISO 19163-2 and 19123-2. And thank you very much for the contributions from the ISO OGC, and especially for the project teams of the ISO 19105, ISO 163-2, and ISO 19123-2. And thank you very much. This is my talk.
Thank you very much for your presentation and sharing with us the story, the user story, or good practice of usage of the ISO 19105 for the conformance and testing in China. So any